Our first sustainability principle is coding practice. As we've just seen, if we want to embody a research contribution in software, we choose a programming language, we create a sequence of steps to solve a research problem, we pass the realization of those steps in programming code to a compiler, and it checks it that we've adhered to the syntax, and if we have, great, the compiler creates our new piece of software, and if we haven't, it sends it back to us with an error. Now the temptation might be to just keep iterating the program until it compiles, but as we've seen, there's a difference between programming code that compiles and programming code that's constructed well and is of high quality and thus overall sustainable. To address this, the idea of coding practices, coding principles has arisen as a list of heuristics for things you should consider, things that you should do when you're writing code to ensure it's of high quality. At the top of most of these lists, which are often very long, is the idea of comments, so little pieces of descriptive text within our programming code that aren't read by the compiler but exist purely to describe what's going on in the code. They're usually prefixed by a given symbol. The second is the idea of organizing our code. So in reality, we can put all our code in a single file, line by line, pass it to the compiler, and it will probably compile. But in reality, we should organize our code better. For example, we should group related bits of functionality into things that we call functions or methods. And we should collect, again, functions that share some common functionality together and put them within a class, and then separate these across different files perhaps. The third thing, the third coding practice, an often popular one, is the idea that we should use proper names and naming conventions for things such as function methods and things like variable names. And to do this, we should adhere to certain standards. So different languages, for example, have different standards, and there are certain principles that cross languages, like the idea of using camel case, which controls the use of capital letters. Finally, as a part of this brief overview, a common coding practice is the idea of failing gracefully, of ensuring that we program robustly so that our code doesn't fail in unexpected situations. So if we're relying on example for situations that are outside of our control in the execution of our program, such as user input, then there's the potential for things that are unexpected to happen. For example, we're expecting a user to enter a number, but instead they enter a letter. Using these things called exceptions, we can make sure that we control, that we respond to these unexpected situations in a graceful way, that we fail gracefully to avoid things crashing in a negative way. Again, it's worth saying that there are some things that some coding practices that are themselves not consistent across different disciplines. So for example, certain people will have certain ways that they use the spaces between lines. Some people will put different numbers of spaces between lines, different indentations, etc. So some coding practices aren't universal. Different people do things in different ways. The key, though, is to be consistent. So what do I get? Why is this better? Well, hopefully it's fairly clear already. So with using descriptive things like comments and proper variable names, I ensure that my code will be understandable even several years from now. And that's important for myself just as much as for other people understanding the code. So if you write a piece of code, put it down and come back to it in 6 months, then in reality, if you haven't used descriptive names, if you haven't done comments, you're simply not going to understand what it's done. This also all speaks to the idea of reusability. So if I package my code in things like methods and classes, then it becomes much more reusable. And as we've said, when I use things like exceptions, my code becomes a lot more robust. So again, what does this have to do? This is nice, this is good, this seems better, but what does it have to do with sustainability? So all of these things contribute to the intelligibility of our code. So if we have descriptive methods, methods with descriptive names even, if we have variables with descriptive names, if we have comments, if we have our code well organized, then it's a lot easier for people to understand our code. And if people can understand our code, then they can maintain it. And remember, this is a principle we looked at that's key for software sustainability. If we want people to be able to come along and update our code in the future so that it continues to work, then the first key thing, the bottom line, is they need to be able to understand it. And that's what these good coding practices contribute to. In the same way, if people want to use our code in their code, and of course they're going to have to understand it, aren't they? So again, this notion of intelligible code brought about by good programming practice all feeds into maintainability, which is a key property of software sustainability. What more is there to know? Lots of things. So there's lots of different coding practices out there. It's not possible to list them all. I would encourage that you go away and read further about the practices that we have talked about and see if there are any more. And most importantly, adopt your own style. Adopt a style that suits you and then use that style consistently throughout your code.